to integrate the internet here so that my end users can access internet as well. So let me check internet router is configured or not. So IP interface brief, no. So let me do one thing, let me configure one IP here, interface loopback 1, and IP address over here is 8.8.8.8.255.255.255.255 exit, then interface serial 3/0. But guys, in real time nowadays we are not using serial link. Here you will use fiber link. Say no set and IP address 1.1.1.2, let's say 255.255.255 dot. What will be subnet mask for /30? Done and save. Internet configuration is done. Let me remove the console of internet because I will not configure anything else on internet router. Now on router number 3, interface serial 3/0, which is connected with internet, say no set, and here IP address. What will be IP? 1.1.1.1. Subnet mask 255.255.255.252. Done. Now to configure NAT, see, just I am giving you one overview of NAT here. Don't worry about the NAT because we will discuss it later. Guys, which type of network this is? Private or public? This is public network, right? And these two are private network, correct? Private network. So we have multiple departments in XYZ corporate. So these are all private subnets. Again, we have multiple departments in AB, C corporate. These are private subnets. And by default, private and public cannot communicate with each other. Private network and public network cannot communicate with each other. So the technology which we are using to make it possible is NAT, network address translation. So that's why I am going to configure NAT on router number 3. We will discuss later how NAT works. For now, don't worry about the configuration and how NAT work. Just keep in mind why I am configuring NAT here, to make communication possible between private and public. And NAT is what? NAT is a protocol, or you can say technology or a process used to make communication possible between private and public network. Now on R3, I can say interface serial 3/0 IP NAT outside. First of all, you have to define which interface is inside interface and which interfaces are outside interface. So serial 3/0 is connected with internet. So this is my outside interface, right? And then rest all interfaces like interface range F0/0, F1/0, F2/0, and F1/0. These all interfaces are inside interface. So say IP NAT inside. Now here I am going to create one access control list for defining the traffic, right? I want to define all internal subnets. So I can use subnet 0.0.0.0. So say access list number, let's say 50, permit 0.0.0, or I can say permit 10.1.0.0, 0.0.255.255, and 20.1.0.0. So these two subnet will match my all internal subnet, right? Now I am going to say IP NAT inside source, match source from list number 50, and then translate the source into the IP address which is running on interface serial 3/0. And actually I am going to configure PAT, so say overload. That's it. Now can I ping 8.8.8 from router number 3? Can I ping 8.8.8? No, because so IP route. See, route is not available for 8.8.8. If you will check the entire routing table, see there are lots of route. So what I can do, I can say so IP route 8.8.8.8 and 255.255.255.255. See, network is not in table. And guys, like 8.8.8, there are million of servers on internet. So is it possible to configure route for each server, for each public servers? No. So here I will configure what default route. Remember the static route, right? We have two types of static route. So I am going to configure one default route here, IP route 0.0.0, 0.0.0, and exit interface is serial 3/0, and next hop IP address is 1.1.2. Now can I ping 8.8.8? Do ping 8.8.8.8. I can ping 8.8.8 from the WAN interface, right? From serial 3/0. And guys, on the internet, ISP will only allow this IP address which is running over here, because you are going to purchase the public IP address from the internet. So your public IP address is 1.1.1.1. So ISP will configure ACL on their interface, and ISP will allow only this IP address. Means except this IP address, no any other IP address are allowed on this interface. Right? So can I ping 8.8 from other interface, from this interface or from the private interface? Yes. Why? Because this time what router 3 will do, router 3 will translate the source. NAT is running, so it will translate source into 1.1.1 every time. Any user, if PC1 will ping to 8.8.8, source IP 10.1.1.1, it will forward to router 2, router 2 will forward to router 3. When router 3 will forward it to ISP, it will translate source. First it will translate 10.1.1.1 into 1.1.1.1, and after that it will forward to internet. So source IP will be 1.1.1.1, destination IP 8.8.8.8. So when ISP will receive the traffic, ISP will generate reply for whom? For 1.1.1. So on the ISP, in the reply message, source will be 8.8.8 and destination will be 1.1.1.1, and then internet router will forward it to router number 3. When router 3 will receive the reply, again it will translate 1.1.1 into this private IP address, and then it will forward to router 2. Router 2 will forward it to PC1. But the issue is, when PC1 will ping to 8.8.8, PC will forward traffic to router number 2. Right? In the traffic, source is 10.1.1.1, destination is 8.8.8.8. But router 2, guys, don't have route for 8.8.8, right? So on router number 2 also you have to configure what? Default route towards router number 3. On router number 1 also you have to configure what? Default route. On router number 6 also you have to configure what? Default route. Here also, here also. If you have 100 number of router in your internal network, so you have to configure 100 number of default route. Am I right? Is it clear? So again, this is impractical. We cannot configure one default route on all router. So what I can do, on router number 3 we have default route. So I can advertise this default route in EIGRP. And once I will advertise this default route in EIGRP, router 3 will start advertising to their all neighbors. And this is how all routers will get that default route. Yes or no?
Yes, sir.
So to advertise the default route in EIGRP, say router EIGRP as number 10. And before advertising the default route, you can check the routing table of router 2. So IP route, there is no any default route available, right? Gateway of last resort is not set. So if router will not find any match in the routing table, then it will drop the traffic. But if you will configure the default gateway, so gateway of last resort will become next hop IP address for default gateway. So now on router number 3, say default information originate. Default information in which direction? In out direction. Default information out. Now on router number 2, so IP route, is default route available? No. So you know why router 2 is not getting default route? Because of route filtering. On router 3, or even I think on all routers, we had configured the filtering yesterday in the last class. So what I am going to do, I am going to remove those filtering from router number 2 and router number 3, even from the all router, because today again we are going to perform route filtering. So router EIGRP AS number 10, and do so run section EIGRP. So let me check the filtering configuration here. So you can see This is the distribute list configuration. Say no to this command. Right? Now guys, on router number 3, am I filtering any route in odd direction? Do so run section EIGRP. Yes. So let me remove this route filtering configuration as well. Say no here. And now go to router number 2 and let the EIGRP neighborship resynchronize. And show IP route. So IP route done. So IP EIGRP topology. Config T router EIGRP number 10. Do so run section EIGRP. So where is the default information originate command? Default information out, and after that the access list not required here. Do so run section EIGRP. Router 3 is not accepting the command default information. What is the command? Default information to distribute default information. Default information, that is fine. So router 2, so IP route, it is still not advertising. What is the issue?
Command is not correct.
Command is not correct on router number 3. Here we should have one option, right? Originate option, I think.
Sir, I think it is EIGRP 10 default information originate. ऐसा कुछ है क्या?
EIGRP yes number 10.
10
EIGRP default. एक बार चेक करो क्या डिफॉल्ट ओरिजिनेट का कमांड है.
ठीक है सर, मैं गूगल
Do so run section EIGRP, like how to advertise default route in EIGRP. Okay, fine, and do so run section route. So default route is there, and next hop IP address is also reachable, so it will install this default route in routing table. So IP route include 0.0.0, let's say. Do so IP route. So yes, default route is there in the routing table, that is fine, and ping 8.8.8.8. Ping is also working. Actually here command is different. See, if you want to advertise default route in case of OSPF, then you will run same command, default information originate. But in case of EIGRP, command is different. Router EIGRP ES number 10, and here I can advertise the summary address IP
Root.
Not here. On the interface F0/0 IP summary address for EIGRP is number 10 and the network is 0.0.0. This is also one option, but I think default information originate command is also, guys, valid in EIGRP to advertise default route. But on this router, on this IES, I am not able to run that command. We'll see it later. But for now, what we can do, we can advertise a summary route of 0.0.0. Subnet mask 0.0.0.0. Wildcard I mask subnet mask this one and then hit enter. Now EIGRP neighborship has synchronized. Now let me take you to router 2, and on router number 2 let me check the routing table. Now you can see it is advertising the default route, correct? Now can router 2 ping internet? Ping 8.8.8.8. Ping will not work. Why ping is not working? Because actually router 2 is pinging 8.8.8 from their exit interface, from this interface, and IP address of this interface is 23.1.1.2. And guys, router 3 is translating for which IP addresses? It will perform translation for the subnet which will match in access list 50, and in access list 50 we have defined 10 and 20 subnets only, correct? So from the LAN interface, router 2 can ping from the fast Ethernet 0/0. So say ping, and if you want to verify it, simply here you can run command so access list. So you can see in access list 50 we are matching these two subnets. Now on router number 2 ping 8.8.8 and say source fast Ethernet 0/0. You can see ping is working, yes or no? Means my LAN user PCs can access internet now. Am I right? Even I can access internet from fast Ethernet 1/0, which is connected with sales department. See, ping is working. Fine. Clear?
Sorry, if you don't mind, can you elaborate again? I didn't get that. Sorry.
No, I have configured one default route on router number 3, brother, to forward traffic towards internet, and then I have advertised one summary route from router number 3 to router number 2. I have advertised 0.0.0.0. So router 2 have default route in their routing table. So router 2 can forward traffic to internet. That's it. This is what
So,
I have explained.
Okay, sir, but the default route, okay, advertise any package, okay, through which interface? If 1/1.
On router number 3, I have advertised default route from 0/0. So that's why router 2 have default route now. Router 1 don't have default route till now. See. So
Thank
IP
you.
route. Here we don't have default route. So actually there is one
Thank you.
command like in router EIGRP as number 10. Here you can run command default information originate like this. And if I will remove filtering from router number 1 also, router EIGRP as number 10 and do so run section EIGRP. Let me check the filtering. So here is the filtering. Let me remove this command. Say no to this. Now wait for EIGRP neighborship resynchronization. And so IP route EIGRP. But I'm not learning default route. So this command is actually not working here. That's why I have advertised summary route. But again, on router number 1 also I need default route. So what I can do, I can advertise one more summary route from 1/0. Interface F1/0. Say IP summary address for EIGRP as number 10 and address is 0.0.0 and wildcard mask is 0.0.0. Now go to router number 1 and check the routing table. So IP route include 0.0.0. So this router is learning default route from EIGRP protocol, right? The EIGRP. Next stop is 13.3, which is IP address of router 3. Now router 1 can also ping internet from their LAN interface. So ping 8.8.8.8 and source fast Ethernet 0/0C. Ping is working, right? From fast Ethernet 1/0 also ping is working. But now ABC corporate means these department, finance, management, sales, voice, these users can still not access internet. The reason, router 6 don't have default route. So IP route. If router 6 don't have default route, then router 6 is not going to advertise to router 4, router 5. So these routers in ABC corporate don't have default route. So on router number 3, what I can do, I can advertise one summary address from F2/0 as well. So interface range F2/0 and F1/1. On these two interface, I'm going to advertise summary address. So say IP summary address for EIGRP as number 10 and address is 0.0.0, 0.0.0. Now see EIGRP neighborship has synchronized. Now you can check the routing table of R6. So IP route EIGRP. So here see I am learning default route. And on router number 4, so IP route EIGRP. So router 4 don't have default route. Router 4 still don't have default route. Now question is why router 6 is not advertising? Because see router 6 is a part of two EIGRP process, EIGRP process 10 and 20. Right now router 6 have default route in EIGRP AS number 10 database, right? If you will check the database, means topology table, so IP EIGRP topology. So where is the default route? Here is the default route. For which AS number, guys? For AS number
10. Okay.
for AS number 10.
Has 10 also have it?
So IP EIGRP neighbor. So we have two neighbor for 20 and two neighbor for 10. This time this router is learning default route from which neighbor? From EIGRP as number 10. So IP EIGRP topology and 0.0.0. Check the detailed information of default route. State is passive, okay, fine, FD. Received from which neighbor? From 63.1.1.3. From redistributed, send flag, okay, leave it for now. Metric. Originator router ID means who is originating this default route. So router 3. Actually, you know, on router number 6, we have default route in both topology table, in 10 also and in 20 also, because we are redistributing EIGRP 10 into 20. And then it is receiving same default route from other neighbor also, from 36.1.1.3. Here it's internal subnet, here it's external subnet. This is redistributed, here it saying internal. Now wait for some time, let me check the detailed information. Originator is this one. Wait, let me do one thing. On router number 3, I am going to remove summary command from F1/0. Now I am advertising summary from F2/0 only. So here say no IP summary address for EIGRP AS number 10 and address is 0.0.0.0.0.0. Again EIGRP neighbors if has resynchronized and do so run interface F2/0. So on this interface, see the summary address is correct. Okay. Now on router number 6 again. So IP route EIGRP. So default route is there from the upper link. And so IP EIGRP topology 0.0.0.0.0.0 to open it in detail. So this time this router is learning this default route from this router, originator router. This is not the IP address of router, this is router ID of router. So we have concept of router ID also as well in EIGRP, but we will discuss that in OSPF because concept of router ID is same. So both all routers in the EIGRP domain will elect one IP address as a router ID, or you can configure router ID manually. There is one successor only, and this is the FD. Okay, from this, from redistributed. Why redistributed? In EIGRP 10 for 0.0.0 one successor, and so IP EIGRP topology. So here we have default route in EIGRP AS number 20 and in EIGRP AS number 10 also we have same default route. So actually we are redistributing EIGRP 10 into 20. So that's why you can see default route is available in the topology table of both process. Correct? Now this router should advertise this default route to router number 4, but so IP route. Here we don't have default route. So on router number 6 I am going to add one command, router EIGRP AS number 20 and default information out. And now it will, I think, start advertising default route. Not advertising. See guys, I think this is a problem of simulation only, because router 6 should advertise default route in AS number 20 because redistribution is already configured on router number 6, but it is not advertising 0.0.0. So that's why here gateway of last resort is not set. Let me check few more commands if any other commands are available over here. Router EIGRP AS number 10. Oh, do so run section EIGRP. So we have run default information out in which AS number? In 20 or 10? Command is even not there. (20) and default information except output default information, input default information. Why it's not working? Why it is not advertising? Router 6 have installed it in their topology table. Now router 6 should advertise it. Oh, I think because of filtering here, right? On router number 6 also we have some filtering. Do so run section EIGRP. Just a minute. So you can see distribute list is there, no default information in there's no any filtering on router number 4. So run section EIGRP. Is router 4 is filtering any route? Yes, router 4 is filtering route, and see in the access list 10. So access list, and guys, access list 10 will permit only these two subnet. So this is the reason why this router is not getting default route. Say router EIGRP as number 20 and do so run section EIGRP. I'm going to remove the filtering configuration here, distribute list configuration. Say no to this. Done. And then on router number 6 I had added one command in EIGRP 20. So say router EIGRP as number 20, and I'm going to remove this command, default information in. By default this command is enabled, so let me enable it. Now again I am going to verify router 4 routing table. This time I am expecting it should have one default route. So IP route and include 0.0.0.0, and see guys, this time we have default route on router number 4, and this default route is external route, right? EX, because router 6 is redistributing default route from EIGRP S number 10 to S number 20, right? So IP route EIGRP 0.0.0.0.0. You can see route type is not EIGRP, like this. You can see route type is external. AD value is also 170. Route type external. Now can router 4 ping to internet? Let me try. Ping 8.8.8.8 source F0/0. See, ping is working, yes or no? And router 4 can ping from F1/0 also, means management departments can also ping to internet. See, ping is working, right? And now finally, which router I have? Router number 5. So let me take you to router 5, and on router number 5 do so run section EIGRP. Let me remove the filtering first, and this one, say no to this, and so IP route. So now you can see here also we have one default route. Just wait for some time. Do so run section EIGRP distribute list router EIGRP S number 20, and no to this distribute list. No. So IP route EIGRP. Done. Here also we have default route. So now sales department and voice can ping internet 8.8.8 and source F0/0. Ping is working, and source F1/0. From this interface also you can see ping is working. Done. Can I move to the filtering part again? Now you can see I have set up the internet as well. All department users are able to access internet. Now guys, I am going to up one more neighbor between router 3 and router 6, as we have two link. But so IP EIGRP neighbor. So you can see we have only one neighborship between router 3 and router 6. 63.1.1.6 and 36. Both neighbor are up. Okay, fine. Both neighbors are up. But I am advertising default route from F2/0 only. So if you want to advertise from both interface, default route from the both interface, what you can do? You can advertise a summary from 1/1 as well. So config T interface F1/1 and IP summary address for EIGRPS number 10 and address is 0.0.0 Now go to router number 4 and check routing table. So IP route. So default routes is available on router number 6. So IP route. And router 6 is performing what? Load balancing for default route, because router 6 have same default route with from two different neighbor with same AD value, same matrix, same prefix length. Correct? Now let me tell you one scenario where you need to use extended ACL for route filtering. See, R6. R6 is learning all 10 network like 10.1.1.0, HR department, sales, admin, servers, these subnets. And router 6 is performing what? Where is the subnet? 10 subnet on router number 6. So IP route EIGRP. Sorry, so IP EIGRP topology. Yes. Router 6 is okay. Let me do one thing. Let me add one more link between router 2 and router 3. I can add one more link between router 2 and router 3 as well, right? Or I can add one more router for redundancy. For redundancy between router 2 and router, let's suppose this is the server department, right? So guys, here I have critical traffic, but link between router 1 and router 3, we have only one link, right? But I want to add one more link for backup. Or you can add one router here and you can connect like this. So I'm not going to add router, I'm just going to add one link here. So see, after the adding link, let me add serial link here. Serial 3/3 and serial, not serial. Is any fast Ethernet link available? Yes, fast Ethernet 2/1, fast Ethernet 2/1. Done. Now here we have fast Ethernet 2/1, fast Ethernet 2/1 is the lower link and 1/0 is the upper link. On the lower link, I am going to, let's suppose, use subnet 31. So on router number 1, let me configure the IP on R1. So run section EIGRP. So I am running network 0.0.0 command. Only I need to configure IP. It will automatically enable EIGRP. So interface F2/1, say no set, and IP address. IP address is 31.1.1.1 255.255.255.0. Exit. Now go to router 3 and say interface F2/1 no set and IP address. IP address over here is 31.1.1.3 255.255.255.0. Now on router number 1, you can verify we have two neighborship. So IP EIGRP neighbor. Just wait. Ping 31.1.1.3. Why I'm not able to ping? Yes, ping is working. So IP EIGRP neighbor. We need to troubleshoot the neighborship. Why we don't have neighborship between on the lower link on F2/1. So IP EIGRP interface. So see guys, EIGRP is enabled over here on F2/1 and on router number 3 also. So IP EIGRP interface. So here on F2/0 EIGRP is not enabled. So run section EIGRP. Actually I am not running network 0.0.0 on router number 3. So manually I have to add one more network command, right? I need to add 31 network in the EIGRP. So say router EIGRP is number 10 and network 31.1.1.0 255.255.255.0. Now EIGRP neighborship will come up. So IP EIGRP interface. Now you can see EIGRP is enabled on 2/1, right? And after now if you will check R1, so IP EIGRP neighbor, so you can see we have two neighborship, right? And guys, so IP route EIGRP. Now these 20 networks and external network and all 10 networks, soon it will start performing load balancing. So IP EIGRP topology. In the topology table, how many paths are available for external prefixes? Only one path is available. Only one path is available. That means guys, there is no feasible successor. Am I right? On router number 1, there is no feasible successor. We have two paths, but maybe that path is not matching feasibility condition. What is the feasibility condition? What is the feasibility condition? So
Yeah.
yeah, what is feasibility condition?
FD of the advertised distance should be greater than RD of
Great.
backup.
RD of feasible successor, right?
Yes.
So IP EIGRP topology. Router 3 have 20 network and see the metric is same, correct? So router 3 is doing load balancing. So IP route EIGRP. Router 3 is performing load balancing here. Okay, we don't need to use these two link here on router number 1. See, router 3 is performing load balancing, right, for all 20 subnets, correct guys? Router 3 is performing load balancing for all internal subnet. Here I am going to remove this link, not required, because we can perform lab here. Router 3 is performing load balancing. Router 3 have two path for 20.1.2.0, 20.1.1.0, 20.1.3.0. Now let's suppose on router number 3, my requirement is you need to filter route all 20 subnets on this particular interface from, let's say, this neighbor, from the neighbor on the lower link on router number 3. So IP EIGRP neighbor. So I want to filter all 20 networks from this neighbor 36.1.1.6. Can I configure a extended ACL here? Because this time I need to match source also, like from a particular neighbor I want to filter route. So with the help of extended ACL we can only match what? Source. Here we can even filter this, we can achieve this task with the help of extended ACL. But assume you have a topology like this. Router 1, router 2, router 3 and router 4. And guys, router 4 is advertising X network. So router 1 will get X network from both neighbor, from router 2 also, from router number 3 also. And on router number 1 you want to receive X network via router number 2 only, right? So let's suppose admin have told you to configure route filtering on router number 1 for X network, and X network should be reachable from 12.2, from router number 2 only. That means you need to filter X network from which neighbor? 13.3. So here I need to define source as well as destination. I have to deny source as well as destination. Correct? So like on router number 3, what I can do, see on R3, I can create one access list, let's say number, not extended, because in extender you cannot match source. Whenever you need to filter route on the basis of source address, right? You want to match destination network as well as source. From a particular source I want to filter this network. So that time you will use extended ACL, right? You cannot match source with the help of extended ACL. You can only match one network. Either it can be destination or it can be source. So access list 101, let's say extended ACL. Then deny which protocol? Deny, and then IP protocol, and after that source address. From which source? From 63 from the lower path, 63.1.1.6. Wildcard mask 0.0.0. Or I can say host, means the IP address of source, 63.1.1.6. From this neighbor I want to deny the network. Now which network? Destination network 20.1.0.0 to for wildcard mask 0.0.255.255, and then access list 101 permit IP any, permit IP any, or even you can ignore this command, because right now router 3 is only learning 20 network. But if router 6 is advertising guys lots of prefixes to router number 3, and I want to filter only 20 network from a particular neighbor, then I have to run this command also, access list permit IP any. But now we have only 20 subnets, so I can ignore it. Access list 101 permit IP any. Now I can apply this access list under EIGRP. So say router EIGRP is number 10 and distribute list number 10 direction in. Now you can see show IP EIGRP topology. Wait for EIGRP neighborship resynchronization. Yes, EIGRP has resynchronized, and now see the topology table. For 20 network is not there. What happened? Can anyone tell me what is the issue? I have applied the ACL on all the interfaces. I have applied the distribute list on all the interfaces. So router EIGRP is number 10, and say no to this command, and then distribute list number 10 direction in. On which interface? On fast Ethernet 1/1. Again EIGRP neighborship will resynchronize. Just wait. And so IP EIGRP topology. Now see the 20 network. 20 network is there, but via upper link only, right? From this neighbor 36.1.1.6. So whenever, always keep in mind like this, whenever I want to filter filter routes on the basis of source address from a particular source, that time we will use extended ACL to filter route. Now hope extended ACL route filtering with extended ACL and extended ACL is cleared. Now I am going to remove this command also, so IP.EIGRP. Now this router is not performing load balancing for 20 networks. Once I will remove this command, router EIGRP is number 10, and let me say no to this command. Again, this router will start performing load balancing, so IP.EIGRP. Just wait for resynchronization. See, EIGRP protocol is slow. Right now again you can see it has started performing load balancing. Now question is where I will use prefix list and route map. Right? We have two more options to filter routes. Prefix list and route map. So guys, any question in route filtering with the help of extended ACL and extended ACL?
No.
Hello everyone, clear? All. I can remove this interface. Go to interface, serial 2/1 and say shutdown no IP. Interface serial on router number 1, serial 2/1. Oh, I have removed the interface. Done. Now route filtering with the help of extended ACL, extended ACL. Before talking about route filtering with the help of prefix list and route map, first try to understand what is prefix list and what is route map. Like first we have discussed access list. What is access list? Then we have seen how to use access list to filter route. In the same way, now we will learn what is prefix list, what is route map, and then we will see how we can filter the route on the basis of prefix list and route map. So guys, prefix list is also one features on Cisco IS which is used to permit or and allow traffic. But prefix list is more efficient than access list. Prefix list is more efficient than access list. How? A prefix list and route map are tools used in networking to control and manage routing decision. A prefix list is a mechanism used to control distribution and acceptance of route in the routing table. It is primarily used to filter IP prefixes based on their network address and subnet mask. We are doing same thing with the help of ACL also, right? Then prefix lists are more efficient and easier to manage as compared to traditional access control list when dealing with the route filtering. When you will configure the prefix list, you will see how it is easy to manage it as compared to access list. Key features: efficiency. Prefix lists are processed more efficiently than ACL, making them suitable for large routing table filtering, route filtering based on IP prefixes and subnet mask. Done. Prefix list can be applied to various routing protocols such as BGP, OSPF, EIGRP. Example of prefix list. Let's say I want to permit this network and deny this network. So tell me, what is the difference between these two subnet first? What difference you are able to see here? Difference is, guys, in terms of prefix length. So whenever we will manage subnets on the basis of prefix length, that time I will use what? Prefix list. Whenever I will manage routes with the help of or on the basis of prefix length, then I am going to use what? Route map. Done. So see, I am denying this network. If you will configure ACL like this, deny 192.168.0.0/16, 0.0/16, and then you will say permit, not sorry, permit 192.168.0.0/16, and then deny 192.168.1.0/24. In ACL, what will happen? If a router will receive a traffic where destination is 192.168.1.50, will router allow this traffic or deny this traffic, guys, according to this ACL? Tell me. Will router allow the traffic or router will deny the traffic? Will router allow this traffic or not? ACL will check first this entry. In this entry, what I am saying, only match 16 bits. So it will match this. At these two octets are matching, router will allow it. Router is not going to check this statement. Yes or no? But in case of prefix list, router will deny this network information. In case of prefix list, router will deny this traffic, because prefix list first will check this entry again, right? And in this entry, it will check 2 octet. In first octet value is 192, in second octet value is 168, and it will ignore these 2 bits. So in IP prefix list, actually it is going to check all 32 bits. While configuring, you will see when I will configure the prefix list on router, prefix list will deny this traffic, but access list will allow this traffic. This is the difference. If you are not able to connect the dot, don't worry. While configuring, I will tell you. So in the prefix list, what we can do, we can filter the traffic on the basis of prefix length. Mainly we are focusing on prefix length in the prefix list. In the ACL, mainly we are focusing on the network ID, match bit. So see here what it's saying, the prefix list, this is the name of prefix list, filter route. Permit any route with the 192.168.0.0/16 range. It deny route specifically with the 192.168.1.0/24 range. So once router will receive the traffic, it will check prefix list, and in the prefix list, here 24 bit will match. Here only 16 will match. So prefix list will use this entry, this statement, where more bits are matching. Then route map. Again, in access list or in prefix list, we can only match network ID, means network, subnet you can say, and subnet mask. Subnet and subnet mask. But guys, sometime you need to match other parameters also, like metric, tag. So in that scenario, you have to use what? Route map. So route map is a, again, mechanism which is used to match many parameters. Route map is actually used for conditional routing. Conditional routing means if let's say source is this one, destination is this one, then only allow the traffic. If metric is this one, then deny the traffic. If tag value is this one, then allow the traffic. So we can put condition, right? And we can call to access list and prefix list under route map. Let's say I want to define a network, this network 10.1.1.0/24, and I want to add some metric with this network. Metric over here is, let's say 100, but I want to add 20 more metric. So I can define this network in access list or in prefix list. Let's say ACL 10 is identifying this network. Now under the route map I can say match subnet from this ACL, and then if match will found, then please add metric 20. So all this subnet will have what metric? 120, like that. So this is what conditional routing. First it will match the network with the help of ACL. If match will found, then it will take action. Clear? Is it clear? So see here, what is route map? A route map is a powerful and flexible tool used for controlling routing policy. It can modify or filter route based on various criteria. Route map works by defining a series of condition and action. Condition then action. If condition will match, then it will take action. Key advantage, versatility. Versatility. Route map can match various route attribute. Route attribute means your AD value, your metric. And guys, in BGP we are going to use lots of route map, right? Because BGP is all about route map only. You know the reason why we are using BGP nowadays? Because in BGP you have lots of options to manipulate the route, to filter the route, to perform path manipulation. We have lots of options. We have lots of attributes. In EIGRP we have AD value and metric only, right? On the basis of metric only, EIGRP is going to calculate what? Best path. And in the metric it will use K1 and K3, bandwidth and delay. So to perform path manipulation you have only two options, right? You have only K values. But in BGP you will see you have lots of attributes to perform path manipulation. This is why we are using BGP nowadays. So route map can match various route attributes such as prefix list, ACL and route metric, and on the basis of that it will take action. Like I can say, I can tell to route map, please match metric. Match metric. If metric is 100, then deny it, which is not possible in case of ACL and prefix list. Clear? Are issue with network? Am I audible now?
Yes, sir.
Yeah. Clear? So you can say it is used for conditional logic. They can set condition and take action based on those condition. Structure of route map. Match condition. Define what criteria the route map should look for. It can look up ACL, it can look up prefix list, it can look up for metric, for AD values, and on the basis of that criteria you can perform the action. So I specify the action to take if the match condition are met. So this is the syntax to configure prefix list, IP prefix list, and the name of prefix list. This is name. Then we can define the sequence number, after that action, permit or deny. In the route map syntax is route map and the name of route map. Set metric is the name of route map. And what I'm saying, permit sequence number 10. Route map, the name of route map, after that action, and then sequence number. And what I am saying to this this route map, match IP address from prefix list, filter route. This is name of my prefix list, right? And guys, in the prefix list, in the filter route prefix list, I am allowing this network and denying this network. So if match will found in the route map is going to match the condition from from the prefix list. If match will found, then it will set metric 50. So what I am saying next, set metric 50. So the route map set permit route match the criteria. It uses the prefix list, filter routes as the match condition, and after that it set the metric of 50. Scenario, let's say a company has multiple branches and they want to control the routes advertised between them. Or let's suppose again a router is connected with multiple departments in your scenario, right? We have two company here and lots of departments. So in this scenario, I can use route map like on router number 1, let's say. On router number 1, see, so IP route, let's say this network, 31 network. So IP route, what happened? Why we don't have route here? So IP route. So IP EIGRP neighbor. So we have neighborship on router number 3. So IP route. Here we have routes. So run section EIGRP. Filtering is not there on router number 3. So run section EIGRP. We have only default route. What happened? Router 3 is only advertising summary network. So IP route EIGRP. So actually this is not the correct way to advertise, to yes, advertise default route in case of in EIGRP. So from the interfaces like F0/0 and F1/0, I am advertising summary address. That's why on router number 2 and router number 3 you are not able to see prefixes. But that is also fine. Routes are not available, but I can ping to ABC corporate, any branch. Let's say I want to ping 20.1.1.1 and source 10 dot, not 10, source 10, yes, 10.1.3.1. On router number 1, 10 dot show IP interface brief. Last IP address from the subnet. Yes. So source is 254. Ping should work. Why ping is not working? Let me do one thing. Let me take you to R3 and show IP route 20.1.1.0 255.255.255.0. So route is available in the routing table. And then on router number 6, so IP route EIGRP. So router 6 don't have 10 network. This is why I'm not able to ping. What is the issue? So run section EIGRP. on router number 4, so IP. See, on router number 6 actually we have routes in the topology table, you can check. So IP route EIGRP. Here we have 10 subnet. No, on router number 6, so IP EIGRP topology. In the topology table of EIGRP 20, we should have 10 subnet. 10 subnets are not available here, right? 10 subnets are even not available here because of some reroute. So IP route EIGRP is default route there. Yes, default route is there on router number 4. So IP route EIGRP default route is there. Then router 1 should able to ping this IP address. Okay, the IP address is incorrect, right? 254 is the IP address of router 4. Router 4 F0/0 ping. See, ping is working, right? So even we don't have a specific route, but because of default route, so IP route, because of default route I am able to ping. So now you can see, so IP route EIGRP. Through EIGRP I am learning single route, right? That is default route. So router 2 and router 1, these two routers have default route, right? So whenever these router will not find any match, it will forward traffic to router number 3. But router 3 have all individual prefixes, right? So if router 3 will receive traffic where destination belongs to 20 network, it will forward to router 6. If destination is 8.8.8 or any network which is not available in the topology table, then router will forward it towards internet by using default route. And same thing happening in ABC corporate. Router 4 have default route, router 5 have default route towards router number 6. So router 5 and router 6 will forward traffic on the basis of default route to router number 6, and router 6 have also default route towards router number 3. So if route is not available, no problem. Router 6 can forward traffic to router number 3. And on router number 3 again, if destination belongs to 10 network, then it will forward to either router 2 or router 1. If destination is 8.8.8, then router 3 will forward towards internet. So this time only router 3 have all network information. Apart from router 3, all routers have default route. So now routing table of all router except router number 3 is reduced, right? Routing size is reduced, routing table size. So it is good for performance. It is good for performance. And guys, in access control list, we have gap in sequence number of 10. Like if you will configure two statements in one access list. So first statement will get sequence number 10, second statement will get sequence number 20. But in the prefix list, we have gap of sequence number 5. Okay. And in prefix list, I am going to use some keyword here, right? Like LE. LE stands for less than. LE stands for less than. Then GE. GE stands for greater than. Right? And guys, last keyword is 0.0.0 means any, or you can say all. Done. So let's suppose I want to filter all prefixes whose prefix length is starting from 25, whose prefix length is starting from /25 and ending on, let's say, /28. So I want to filter those prefixes whose prefix list is 25 to 28. So now let's suppose here my prefix length is 24, here my prefix length is 25, Here my prefix length is 26. Here my prefix length is 27. Or I can create some more LAN on router number 5. Let's say on router number 5 I am going to add some subnets. On router number 5 we have some subnets like 50.1.1.0/24, 50.1.1.0/25, 50.1.1.0/26, and 50.1.1.0/27, 50.1.1.0/28, and 50.1.1.0/29. So let's suppose these are LAN connected with router number 5. Let me configure these loopbacks. On router number 5, go to config T and say interface. Interface loopback, let's say 10, and IP address is 50.1.1.1. Subnet mask 255.255.255.255.0. Then interface loopback 11, and IP address is 128. So it is overlapping. Let me do one thing. Let me change 1/3 octet value. Here value is 1. Here value is 2. Here value is 3. Here value is 4. Here value is 5. Here value is 6. Understand how we can filter out on the basis of prefix length. Because suppose you are working in a company, you are a network engineer in a company, XYZ company, and that company is receiving routes from multiple branch offices, right, or from the multiple networks. You are receiving one subnet, let's say 100 number of subnet or 10 number of subnet with /25 from a particular branch, let's say from Delhi. My headquarters is in Mumbai, and we have multiple branch offices in Delhi, Bangalore, Ahmedabad. So from the Delhi, I am learning all subnet with /value 25. I am learning all subnets from Ahmedabad with /26, and all subnet from Bangalore with /27. So if you want to filter all the prefixes, you don't know what is the network ID. You want to filter all the prefixes coming from Delhi and Ahmedabad. So you know what prefix length. So on the basis of prefix length, you can perform filtering. Or let's suppose in these branches we have multiple departments. Like in all branch offices we have 3 departments. One is sales, one is HR, and one is, let's say, IT. At all branch we have these 3 departments. Guys, sales department is advertising routes with /24. HR department is advertising prefix with /25, and IT department is advertising network with /26. Now if I will tell you to filter route which is coming from IT department, filter the route which is coming from IT department, you can filter, but that time you cannot use access control list. You have to use what? Prefix list. Clear? So prefix list is nothing but, you can say, advanced version of ACL, advanced version of access control list. So here I am going to say 50.1.2.1/25, then loop back 12. Here IP address is 15.1.3.1/26. What will be subnet mask port /26? 190?
192.
192. Then loop back 13. What will be subnet mask port /27?
224.
Good. 4. Then loop back 14. And what will be subnet mask port /28?
240.
240. 5, then last loop back 15. And what will be submit mask here for /29?
248.
248. So say 248. And now a router EIGRP AS number 20 network 0.0.0. So IP EIGRP topology. So you can see this router have installed these all 50 subnets in their topology table. Now it will advertise to router number 6. On router number 6 also you can check. So IP route EIGRP, right? Router 6 is getting all 50 prefixes. Now on router 6 will advertise it to router number 3 to router number 3, because here we have redistributed 20 into 10. So on router number 3 also, so IP route EIGRP. See, we have all 50 subnets, and router 3 is performing what? Load balancing. Now I want to filter prefixes whose prefix length is starting from 25 and ending on /28. So see what I can do. I can create one access control, prefix list. Command will be IP prefix list, the name of prefix list. Let's say name is filter route. Filter routes is the name of my prefix list. And then deny. Which network? See, either I can say 0.0.0 means any network, right, whose length is starting from 25, means match any network less than and equal to 25. So this command will match all network whose prefix length is less than and equal to 25. Got it? Or I can define the network. Let's say 50.1.0.0. All subnets are matching. Then say /16. So now what this prefix list will do? This prefix list will match 16 bits value. And after that I am saying check the prefix length. If prefix length is greater than and equal to 25 and less than and equal to 28, then take the action. Which action? Deny. Right? So first this router is going to check first octet and second octet value. If these two value will match, then it is going to check prefix length. If prefix length is greater than and equal to 25 and less than and equal to 28, it will deny the traffic. And after that I need to allow rest all. So say IP prefix list, again same name, and permit. All network means 0.0.0. Permit all /0 any submit mask, and less than and equal to 32. So less than equal to is network bits. Got it? Match bits. So this command will allow all networks, any network, any submit mask whose prefix length is less than 32. Now hit enter. Do so IP prefix list. See, we have first prefix list with sequence number 5, second prefix list statement with sequence number 10. This prefix list statement will deny traffic whose prefix length is greater than and equal to 25 and less than and equal to 28. If match will not found in this statement, in this rule, then it is going to check this one, and this will allow all the traffic. Now again I am going to apply it in EIGRP. So say router EIGRP as number 10 and distribute list. And guys, distribute list, EIGRP as number 10, and then distribute list. And see, earlier I was calling to access control list here, but this time I am going to call to prefix list. This time I am going to call to prefix list. So say prefix and the name of your prefix list. Name of your prefix list is filter route. So let me copy the name and I'm going to paste it over here. And then direction, in which direction? In the in direction, right? Wait for EIGRP neighborship resynchronization. Done. And check the routing table. So IP route EIGRP. Where is the 50 subnets? You can see 50.1.1.0/24 is there, and 50.1.6.0/29 is there. So all rest prefixes are filtered. Yes or no? Hello?
Yep.
Clear, guys? Let's say I want to filter all the prefixes. See, we have some prefixes with /25, like 20 prefixes. I want to filter all the prefixes whose prefix length is 24. What I can do? I can create a prefix list. Again, IP prefix list. Name is, let's say, Cisco. Name of prefix list, Cisco. Then what I can say? Deny 0.0.0 means all subnet whose length is greater than and equal to 24 and less than and equal to also 24. And after that, IP prefix list, name Cisco, permit 0.0.0/0 less than or equal to 32. Now if I will apply this prefix list on EIGRP, router EIGRP S10 distribute list number, sorry, name Cisco and direction. Wait for EIGRP neighborship resynchronization. I'm getting noise from somewhere. Please keep yourself on mute if you are not speaking. Done. And show IP route EIGRP. Now you can see it have filtered all the prefixes with prefix length 24. Now only prefix length 25, 26, 27, 28, 29 are there. Clear? Now let me remove the filtering. Router EIGRP S number 10 and say no to this command. Again see show IP route EIGRP. Wait for resynchronization. Done. And see. Now it is learning all prefixes. Now let's suppose, see, metric for all 10 prefixes is 30720. Metric for all 20 network is this one. Right? So let's suppose I want to filter those prefixes whose metric is 2565120, or metric for let's say 50 network is this one, right? 2565120. Or you can pick any network. Let's say which network I should filter. Let's say this one, 56 network. 56 network have what metric? This one. I want to filter those prefixes from the routing table who have this metric. So this time I cannot use access list. I can not use prefix list. I have to configure what? Route map. I have to configure route map. So see guys how I can configure route map. Configure T, say route map, and the name of route map is Cisco, and then deny sequence number. If you want to define the sequence number, you can define, otherwise you can leave it. Sequence number, let's say 10, or enter. Then match address or match metric. What metric? this matrix, right? So let me copy this matrix, match matrix. That's it. What I did here, I have created one route map, right, with deny action, and I have matched this matrix. That's it. Now I am going to apply this route map with EIGRP, and I need to permit rest all as well, right? So I can say route map name Cisco and permit sequence number, let's say 11 or 20, and if you will not match anything, then it will match all, right? So I don't need to match anything here, simply I can exit. Only I need to create one route map with permit statement. If there is no any match, then it will match all. That means all rest traffics are matching. Do so route map. So see the route map configuration. Route map name is Cisco, state action is deny, sequence number is 10. Who is matching? This matrix. Match matrix, this one. Then route map with permit statement, sequence number 20 is not matching anything, means it will match all. Now I am going to apply it in EIGRP. So router EIGRP is number 10 and distribute list, and this time I am going to call route map. So say route map and the name of route map Cisco, then direction in. Now wait for EIGRP resynchronization. Oh my god. Done?
Sorry, I have a question,
Yeah.
please. You see, you know that the access list, they have implicit deny any, correct?
Yes.
How about the prefix
In the
list
prefix list
and then
also
route
we
map?
have deny any. So that's why I have run command
Implicit,
na
right?
permit 0.0.0 means permit any.
Yes. And then how about the route map, please?
In the route map, see, if you are creating a route map with deny statement, so it is going to check only that route map. So if you want to permit rest all, you have to create one more route map. If I will remove this route map, see, we have two statements in the route map now. Do so route map. We have two statement, or we can say do so run section route map. So this is my route map configuration here. I am going to remove this route map configuration. Where is the permit? This one. Say no to this. So what will happen? Do so route map. See what will happen? It will check the route map. It will check the route map, and statement is deny. Statement is deny. So if traffic will match, then it will deny. If traffic will not match, then also it will deny. So that's why we have to create one more route map with higher sequence number. Actually, we have to create same. We have to give permit statement in the same route map, right? Because deny any is already enabled in all types of mechanism, you can say, in ACL also, in route prefix list also, in route map also.
Thank you.
Here by default deny any is not running in the route map, but as you have only one route map with deny statement, if entry will not match, then definitely router will deny that. So logically what you can say route map is also denying any at the last, right? So I have to see now routing table. So IP route EIGRP. See, we don't have any route. Reason? Route map. So route map, because there is no permit statement. So let me add the permit statement again. Route map name Cisco and permit sequence number, higher sequence number. If I will put lower sequence number, then it will first check permit statement, right? And here I am not matching anything, so all prefixes will match, so it will allow. So sequence number should be greater than 10. So let's say sequence number 11. That's it. Now again EIGRP neighbors will resynchronize. Just wait for some time. These are advanced concepts of EIGRP. Done. And so IP route EIGRP. Now you can see we have only 10 prefixes. All the prefixes was coming from ABC corporate is filtered, are filtered. Reason? Metric of all the prefixes which are coming from ABC are same, right? So route map. So you can see here in this route map, deny sequence, we have this metric. I'm matching this metric here. Right. Now let me remove the route map configuration also. Say router EIGRPS number 10. And where is the distribute list? This one. Say no. Right. So guys, now I am expecting you can filter route on the basis of route map, ACL, extended ACL, standard ACL, prefix list, and we have covered all theory of EIGRP. So what I am expecting, now you have commands on EIGRP routing protocol. If anyone will ask you any question from EIGRP protocol, you guys can answer them, right? See, metric for all external prefixes are same. Why metric of all prefixes are same? Now this is your question. Let's suppose interviewer is asking this question to you. Why metric of all external prefixes are same? Hello?
Equal cost load balancing.
No. How router 3 is going to calculate metric? With the help of K1 and K3. And while redistributing, you have defined the K1 and K3 value, correct guys? So for all redistributed route, K1 and K3 is going to be same, right? Otherwise, for the subnet which is running over here, will have different metric on router number 3 as compared to this subnet, because delay for this subnet will be lower than this subnet. But it is not using the actual bandwidth and delay, na? It is using the bandwidth and delay which you have defined while redistributing. On router number 6, you can run command. So run section EIGRP. So see the redistribution command. While redistributing EIGRP 20 in EIGRP 10, see the K1 is 1000 kbps and K3 is 255. So it will use same values for all the prefixes which EIGRP is redistributing in 10 from the 20. This is why we have same AD value. Now on router number 3, I am going to do one thing. See, right now router 3 is performing load balancing for all external prefix. I am going to increase little bit bandwidth on F1/0, right? Interface F1/0, or I can add some metric with the help of offset list. Here let me say bandwidth is Done. Now so IP route EIGRP. Clear IP route. Clear IP route. Sorry, clear IP yes route star, and so IP route EIGRP. I have to clear the EIGRP process. Clear IP EIGRP yes number 10 and then neighbor. So IP route EIGRP. Still it is performing load balancing. So run interface f1/1. So bandwidth over here is what is happening? Why it is still performing load balancing? Because guys, for redistributed route, see, when router 6 will redistribute EIGRP 20 routes into EIGRP 10. So for redistributed route, router will not send K values. It will send directly what? Metric. For redistributed route, router will not send K values. Like when router 2 will advertise this network to router number 3, it will send K1 and K3 so that router 3 can calculate metric. When router 3 will advertise it to router number 6, router 1 will also send K values, means minimum bandwidth and total delay. But when router 6 will send to router number 4, will advertise this network to router number 4, so it will send metric, right?
Yes, sir.
So that's why here, even if you will change the delay and bandwidth, it will not impact on metric. Done. So what we can do, if I don't want to perform a path manipulation here, I can add bandwidth with the help of offset list. Now in the EIGRP, redistribution is also cleared. You can redistribute RIP into EIGRP. EIGRP different autonomous system number. Okay, when we will discuss OSPF, then we will see how to redistribute EIGRP into OSPF and OSPF into EIGRP. Right? Now guys, on router number 6, see, on router number 6 I am performing redistribution. So run section EIGRP and go to route config T router EIGRP as number 10, and I am going to remove this command. Say no to this, right? And then distribute EIGRP 20 metric, and after that, see what option I have, route map. So I can say route map, and let me say route map name Cisco, enter. So now while redistribution, this router is going to check route map Cisco, but route map Cisco does not exist over here. Here I can create route map Cisco, route map Cisco permit sequence number 10, and here I am going to say set tag 10, right? And I am not matching any subnet, so it will match all. That's it. Exit. Now go to R3 and see the difference. So IP route EIGRP, is there any difference? No. So IP EIGRP topology, is there any difference? Are you able to differentiate external prefixes and internal prefix here?
Tag is 10.
Yes. Right? So with the help of tag value, now I can differentiate external prefix and internal prefix in the topology table. So let's say I want to check only external prefixes here. So what I can say, so IP EIGRP topology and include tag 10. Tag is 10. Include tag is 10. So it will show me all external prefixes in topology table, right? Now with the help of this tag, we can even perform route filtering. Like on router number 3, I want to filter all the prefixes who have tag number 10. So I can say route map CCNP deny sequence number 10 and match. What match? This time match tag number 10. If tag will match, then it will take the action. What action? Deny action. That's it. Router EIGRP is number 10 and distribute list route map name CCNP direction in low up. Just wait. Wait for resynchronization. Yeah, done. And now you can check the topology table. So IP EIGRP topology. All external prefixes are filtered. So IP route EIGRP. All external prefixes are filtered. Right, guys? So we can use this tag in the route filtering also, for the path manipulation also, right? For the troubleshooting also. So these are some advanced concepts of EIGRP. Then what we can have, is there anything else? Router EIGRP is number 10, and let me say no to this. So IP EIGRP topology. Guys, in the topology table, can you tell me the source of, let's say, this network? Source of this network means this network is coming from which EIGRP? EIGRP 10, 20, 30, 40, which EIGRP? Yes, now you have tag value, right? Now you have tag value. So with the help of tag value, you can identify. But let's suppose there is no tag value, then no. Right? So for traffic identification also we are using this tag value. And we can add these tag values with the help of route map. Done. So I think now we don't have anything else in the EIGRP. So IP EIGRP topology and 20.1.1.0 255.255.255.0. State is passive. Successor 2. Two successors are there on this neighbor. Fine. Origin router ID. See, these origin router ID and these informations are very important for troubleshooting. Load external metric. External protocol is EIGRP. Here you can check the source protocol, right? It can be EIGRP, it can be EIGRP, it can be OSPF. When you will open the topology table in detail, then you can check the source protocol, from which protocol this route is coming. Guys, by default EIGRP uses 50% of bandwidth, right? And it reserves 50% for forwarding data. This is part of quality of service. But if you want to change that, you can change it. What you can do, you can say interface f2/0 IP bandwidth percent. For EIGRP, ES number 10 is, let's say, 30. So IP EIGRP detailed or interface detail fast Ethernet 2/0. So here you can see the bandwidth percentage is, interface bandwidth percentage is 30. So now we have limit the bandwidth for EIGRP. EIGRP is going to use up to 30% bandwidth only, okay? This is part of quality of service. And see, by default speed horizon is enabled. Hello time is 5 seconds. Hold on time is 15 seconds. And you know how to change the hello time, hold on time. You know how to disable next hop self. By default next hop self is also enabled. Then you can check the neighbor. After that, see, we have one more topic in EIGRP, that is EIGRP authentication. But guys, authentication part is, part of security. So you can check the commands, what are the commands to enable EIGRP authentication on routers. But the concept of security will learn in the security portion, right? When I will start the security, then we will see the concept of authentication, EIGRP authentication. Done. For now, I will send you a few commands that you need to run on routers to enable authentication. Otherwise, like, see, if anyone knows the AS number of your router, like on router number 3, what AS number is running. So guys, I can perform attack in your network. On my laptop, I can install one application. On the application, I can run EIGRP protocol. I can connect to the router. Right now, router 3 can form EIGRP neighborship. Or if you are confused with this, so just assume that I can connect my router to R3 and then I can enable EIGRP S number 10 on my router. Then EIGRP neighborship will come up. Once EIGRP neighborship will come up, I will have complete routing table, right? So that's why we have authentication. We have to now secure the EIGRP network. Done. So it should be not like if anyone will connect their router to your router and they can configure the EIGRP, so EIGRP never will come up. No. So tomorrow we are going to start hello. Yes. Okay, one more thing. See here. On router number 3, now I have remembered the command of default information originate. So on router number 3, I am running F0/0 no IP summary address. I am removing summary address for EIGRPS number 10. Address is 0.0.0.0.0. Done. And I need to remove it from F1/0 also. Done. Now you can check router 1. Now router 1 will not have default route. Correct? See on router number 3 what command I can run. Router EIGRP S number 10. And we can say redistribute static, because default route is static route, correct? So if I will redistribute a static route, automatically it will redistribute default route. Now go to router number 1 and check the routing table. Default route. Done. Done, bro? So this is one option. Second option is with the help of summary address, this command. With the help of this command also we can advertise default route. Or guys, I can run command here. If I will remove this command, simply I can run command. Again you can see router 1 don't have default route. Done. Now on router number 3 I can run network 0.0.0.0 command. This command will also advertise default route in EIGRP. Check router 1. अभी आ जाएगा. Okay, this command will work if you have configured default route with exit interface only. So I am going to change the default route configuration. Do so run section route. So let me remove the default route. Where is default route? Here it is. Let me say no to this command. And now I am going to say IP route 0.0.0.0 and serial 3/0. So if I will configure default route with exit interface only, then router is going to consider this network as connected network. So if network is connected, then network 0.0.0 command will advertise it in EIGRP. So go to router 1 and check the routing table. See the default route. Got it? So we have multiple options to originate default route in EIGRP domain. So in the EIGRP domain, maybe you have 1000 number of routers. So all 1000 number of routers will get default route from router number 3. Fine. Even I have one more option, you know, or what we can do on router number 3. See, router EIGRP is number 10 and no network. Okay, network 0.0. is fine. Let me say IP route. Where is the IP route command? This one. Let me remove it. And IP route 0.0.0 0.0.0 and then serial 3/0 and next hop IP address 1.1.1.2. So this time it will not advertise default route in EIGRP. Again you can check the routing table of router 1. See, we don't have default route. Now I can do one thing. I can create one loopback here, interface loopback 100 and say IP address 100.1.1.1. let's say 255.255.255.255. I have created one loopback, and with the help of this loopback I can advertise default route in EIGRP. How? Router EIGRP is number 100 and say IP what happened, interface loopback 100 IP IP default network. Which network? 100.1.1.1 is the IP address, correct? So now this network is going to carry default network, right? Now you can advertise this network in EIGRP. So network 0 command is already running. Now you can check the routing table of R1. It's not working. So this is also one way. I'm missing something here. IP default network. Okay, I think I have to first advertise this network router EIGRP 10, but I am running 0 network command. So IP EIGRP interface. So EIGRP is enabled on loopback 100. Yes. So router 1 should have one default route. भेज दो ना भाई, क्या हो जाएगा? So IP EIGRP topology. I'm missing something here, but this is also one method called candidate of default route. It have not injected, yes, it have injected the default route in their routing table, but with null interface. So run section EIGRP. Don't worry, I will check this configuration. Router EIGRP 100 is also running. 10 network 0.0.0 and these all networks. Let me remove network 0 command. Router EIGRP is number 10, no network 0.0.0 and network 100.1.1.1 255.255.255. So IP interface brief. Okay, go to row number 1 and check. No IP route 0.0.0 serial 3/0 and 1.1.2. Okay, don't worry, I will check this one. What is the configuration of candidate as candidate of default route, right? Then what I can do, I can record a small video on it. After that I will share with you. But guys, tomorrow I will start next routing protocol, that is OSPF, open shortest path first. Very important routing protocol in the routing section, right? Even more important than BGP. Done. So that's all for today. Now if anyone have question, please ask. All clear guys in EIGRP, RIP, routing, static routing, conditional routing, route map, ACL, prefix list. We'll finish routing before 10th of this month, before 10th August.
Sir, BGP भी
और BGP भी है ना, तो BGP को हो सकता है कि हम स्विचिंग के बाद कवर करेंगे, मे बी।
okay.
एक ही बार सारा राउटिंग आपको पढ़ा दूंगा ना, तो पढ़ाने के बाद क्या होगा कि जब आप इंटरव्यू के लिए जाएंगे तब तक राउटिंग भूल ना जाओ। मुझे डर है इस चीज़ों का।
Yes, sir.
एट द एंड मैं क्यों इतना मेहनत कर रहा हूँ आपको सिखाने, मुझे जॉब दिलवानी है आपको ट्रेनिंग खत्म होने के बाद। तो मेरे हेडेक ये है कि ऐसा ना हो कि आप कोई क्वेश्चन का आंसर ना दे पाओ इंटरव्यू में। मतलब आप काम करने के लायक अगर रहोगे नेटवर्क के ऊपर, मतलब एक कंपनी के नेटवर्क को मैनेज करना, ट्रबल शूट करना, कॉन्फ़िगर करना, इम्प्रूव करना, देन बहुत इजी होगी जॉब लेना भी कंपनी में। बहुत इजीली आप जॉब ले सकते हो, इंटरव्यू बहुत इजीली आप पास कर सकते हो। बट अगर आप काम करने के लायक नहीं है, एक नेटवर्क को ट्रबल शूट नहीं कर सकते हैं, मैनेज नहीं कर सकते हैं, इम्प्रूव नहीं कर सकते हैं, तो वो आपसे जो क्वेश्चन पूछेंगे उसका आप आंसर भी नहीं दे पाएंगे। तो अगर हम इंटरव्यू क्रैक कर लेते हैं, दैट मीन्स हम नेटवर्क के ऊपर काम करने के लायक हो गए हैं, राइट? अगर हम काम करने के लायक नहीं है, दैट मीन्स हम इंटरव्यू क्रैक नहीं कर पाएंगे। ये होती है कॉन्सेप्ट।
Yes, sir.
Done. So can I turn off these devices now? Okay. Close. So let's start OSPF, most important routing protocol tomorrow. And now I am sending you the recording within 10 minutes. So make sure before next class you will configure these all filtering by yourself. So you can design a network, like you can design different topology as well, no problem at all. According to you, you can create a topology like for multiple branch offices, and then you can implement EIGRP. After that you can create the scenario for route filtering, and according to that you can perform route filtering. First check route filtering with the help of a standard ACL, then extended ACL, then prefix list, then route map. Also add tag value while redistribution. Use tags to filter route. Which day it is? 7, 8, 7 or 8?
8.
8.